Hello, Algebra kids. This is 10.4, titled The Inverse of a Function. Last lesson we talked a little bit about inverses and how inverses are something that will undo something that's been done. So the inverse of addition is subtraction, multiplication is division, inverse of division is multiplication, inverse of square roots is squaring, inverse of squaring is square root. So this is a function and its inverse. So a function is an operation that calculates something for you. An inverse will undo that calculation. Okay, so it takes what you ended up with and gives you back what you started with. So if the inverse or the operation is putting together a Lego piece, making a Lego diagram, the inverse of that would be taking it apart. If the function is driving the Newton, the inverse of that would be driving back from Newton. Okay, so a formula, the common formula may be converting Fahrenheit to Celsius temperatures. So if a function takes a Fahrenheit and converts it to a Celsius temperature, the inverse will take the Celsius temperature and give you back the Fahrenheit temperature. So it undoes what it normally has been doing. Okay. We're not going to get into a lot of the technicalities with this. The main idea of undoing whatever you've had is going to be important here. These steps right here on page 324, we're going to need that when we find the inverses of functions algebraically. We're going to set y equals f of x. So let's say we have f of x equals 2x plus 4. So there's my function. It's going to take 2 times a number and add 4 in it. So if we want to find the inverse function, we're going to set y equal to f of x. So y equals 2x plus 4. And what we're going to see here is the x's and y's kind of switch, because if we want to inverse, we want to undo what we have. So we're going to switch the x and y in the equation. So x equals 2y plus 4, and now we're going to solve for y. So minus 4 over, so x minus 4 equals 2y, and then I can divide everything by 2. So you could write that as y equals x minus 4 over 2, or y equals, there we go, 1/2 x minus 2. Okay, so let's just go with this one right here. This would be our inverse function. A lot of times they will use like g of x for that. So this function, the inverse, this will undo anything that this does. So let's pick a number for x. Let's calculate f of 10. So x is 10. F of 10 would be 2 times 10 plus 4, so that would be 24. So I have the point. If x is 10, y is 24. Okay, so I started with the 10. I went to the 24. I'm going to take the 24. What is g of 24? So I'm going to start with what I ended with here. So 24 minus 4 divided by 2 is 20 over 2, which is 10. So my inverse function has the point 24, 10, and this will work for any point. Okay, you notice 10, 24 is part of this graph. 24, 10 will be part of this graph. So you can take any point that's going to be on here. Let's say 3, let's not use 3, let's use 8. 820 is a point that's on this graph. Well, if 820 is on this graph, the inverse has to have the point 20, 8. Okay, so the x's and the y's switch. Remember how we switched the x's and the y's? That happens on these points. This happens on the graph as well. Okay. So when you have the question, find the inverse of the relation. These are relationships. These are not functions. Find the inverse of the relation. If 1, negative 1 is on the original relationship, the inverse has to have negative 1, 1. You see those just switch. 2, 5 was on there. Switch them. 5, 2. So that's all you're doing here. Crisscrossing them, switching them. So 4, negative 2, negative 2, 4 has to be done. 8, 6 has to be on there, and 9, 8 has to be on there. Okay? So this is the original, and this is the inverse. So if negative 3 is your input, 4 is your output, if you put 4 into your inverse, you're going to get negative 3 back. If you put 2 in, you're going to get negative 1 back. 2, 0, 5, 1, 3, 3. Okay? Mapping will be the other thing they have. Let's say we have 2, 5, and it maps to 1, 3, 8. So 2 goes to 1, 2 goes to 3, 5 goes to 8. If they want the inverse of that, you'll have 1, 3, 8, and we'll have 2, 5. 1 will go to 2, 3 will go to 2, 8 will go to 5. Okay? So when you have mappings, that's what happens there. You just switch them, connect the lines there. Okay, so exercise 3 through 5, find the inverse function g of x. And then we're going to pick a number, we're going to test it here. So f of x equals x plus 3. I'm going to go y equals x plus 3. Switch them around. X equals y plus 3 and minus the 3 over. So x minus 3 equals y. So that is my inverse function, will be g of x equals x minus 3. So pick a point for x. Let's say, go back up here, x is 2. So if I check this, f of 2 would be 2 plus 3. F of 2 equals 5. So that point is 2, 5. So if I take my output and put it in here, g of 5, I get 5 minus 3, and I get 2. So I get 5, 2. So 2, 5 is on my function, 5, 2 is on my inverse. We're good to go. Okay, so y equals 3x minus 2. X equals 3y minus 2. Switch them around. Plus the 2 over. So x plus 2 equals 3y. And divide by 3. So g of x equals x plus 2 divided by 3. Okay, again, check a number. If AB is on this one, if you have a point AB on this graph, then BA should be on this graph, whatever the number of those are. Okay, you won't see any quadratics. We won't mess with that. Okay, so find the inverse of the function, then graph the function and its inverse. So we're going to graph both of them. So y equals 3x minus 1. X equals 3y minus 1. So add the 1 over. X plus 1 equals 3y, and we're going to divide everything by 3. When we're graphing, it's easier to divide each part by 3. So I get g of x equals 1/3 x plus 1/3. There's my inverse function. So as I practice graphing this, okay. So my original function, let's do that in red, 3x minus 1, so the minus 1 is my y-intercept, up 3, 1, 2, 3 over 1. There's that. And let's go green for my inverse. 1/3 x plus 1/3. So 1/3 is about right there. Up 1 over 3. Or I can go down 1, left 3. There they are. Now, your checkpoint for the graphs is if you draw a diagonal line. This is y equals x, y equals 1x. This is called the identity function. And my red and green lines should be symmetric over that. A function and its inverse should be symmetric over this diagonal line. Okay, and if they're not, you did something wrong. Okay, so this diagonal line, they should be the same distance. Okay, and you can check some points here. Like, this looks like it goes to the point 2, 1. So if 2, 1 is on this, the inverse better have 1, 2, which it does right there. So 1, 2 is on this line, 2, 1's on this line. 0, negative 1's on this one, negative 1, 0 looks to be on that one. Okay, we got 5 minutes before my next class. Here we go. Y equals negative 3x plus 2. X equals negative 3y plus 2. Minus the 2, so x minus 2 equals negative 3y. Divide everything by negative 3. So we get g of x equals, again, negative 1/3 x plus 2/3. They like their thirds. So negative 3x plus 2. 1, 2, 3, 1. 1, 2, 3, 1. Okay, there's that. And negative 1/3 x plus 2/3. Plus 2/3. Down 1, 1, 2, 3. Up 1, 1, 2, 3. Now, if these thirds don't work out, if you have a problem on the computer that doesn't just seem to graph, remember you can pick other points. Okay, you can say, okay, I'll take multiples of 2's maybe, or something like that. Okay, you don't have to use the slope and y-intercept. You can make a table of values for your x's, or use Desmos to help you too. Okay, so y equals, let's check. Here's my diagonal line, up 1 over 1 with this slope, and they look like I made a dragonfly. They look symmetric. They should all meet at the same point, called the concurrency, point of concurrency. So y equals 1/2 x plus 2, x equals 1/2 y plus 2, minus the 2 over x minus 2 equals 1/2 y. Now with this fraction, what happens? Remember, you multiply the 2 over. So 2x minus 4 equals 1y. So g of x equals 2x minus 4. Okay, so that 2, you multiply everything by 2 in that case. Okay. Actually, I'm going to move my chair over, so I'm not so crooked on you. 1, y-axis, x-axis, 1/2 x plus 2, up 1 over 2, up 1 over 2, down 1, left 2, down 1, left 2. Clear the graph. And there's one of them. 2x minus 4, 1, 2, 3, 4. At first I was like, oh, this doesn't look right, but now I'm good. Okay, here's my inverse function, and it's symmetric right over. Okay, so that's your assignment, dealing with the relation, switching the x's and y's, understanding x goes to y, y goes to x, and then finding these functions and doing a little bit of graphing review. So good luck. You're almost there. Keep up the good work. I'll see you soon.